Well, hello everyone for joining today. This is the fourth live stream of the series, and today we're going to take a look at Lobe and Runway, two tools that are trying to make machine learning a lot easier for people who don't know how to code or for people who are getting started with development. So let's just take a look. Before we start, I wanted to share with you a new episode of the podcast that I do, Getting Simple. That is an interview with Adam Menges. So Adam Menges, as you can see here, is one of the co-founders of Lobe AI. And if you go to gettingsimple.com/Adam or just gettingsimple.com, you can get an overview of the stage at which Adam was at when he was getting started with Mike Matas and Marcus Basinger, and how it was to start a company, to work for 2 years on their own and getting this out, and also the acquisition of Microsoft and moving into Microsoft. There are detailed episode notes here, many links, and also detailed chapters or episode markers that let you jump from part to part of the conversation. You can see, you can play the episode here.
Machine learning is actually really easy to understand. It's the same way that we teach our kids. It's the same way that we learn, to be honest.
Or you can choose to go to Apple Podcasts, Spotify, or YouTube. For instance, if you go to YouTube, you're going to see that you can also access those chapters. So you can see here, we can navigate to the different sections of the episode.
And when I started this morning routine, I originally started having like...
All right, so that's one thing, one pointer, and the other one is for, so this was released past Monday. And if you go to the list of episodes, you're gonna be also, let's see where this is. There is an older episode with Cristobal Valenzuela, that is the founder of Runway. And similarly, he explains a bit the logic behind it and many machine learning concepts. Okay, so let's go and take a look at what Lobe AI is first. So Lobe AI is a tool that was released on Monday and that tries to make machine learning more accessible for everyone. It uses on the backend or in the inside TensorFlow. So this is a tool that we're going to be seeing in many of the videos here, and we're going to be using. So it uses TensorFlow without you really knowing, to let you create a machine learning model without touching a line of code, and then exporting it in TensorFlow format, in TensorFlow Lite format, and in a way that you can also serve it on your machine for development in a way similar to what Runway lets you do. All right, so first thing we'll do, we just click here and download. So I'm just gonna write my details here. We're gonna train custom image classification models for our photos and drawings. Where I'm in Spain, accept. Just gonna go here, put my email. I'm gonna click on download. Right, so Lobe starts downloading now. So it's 580 megabytes. Lobe is a cross-platform application that was built using Electron and I believe React. And we go to GitHub, we go to Lobe, we can see there are many tools that the Lobe team has published already for us to be able to create our own applications to use our machine learning models in different environments. So you can, you have boilerplate code for Python, for Android apps, for iOS, for building apps for the web, for .NET, C# applications, image tools, and I'm not sure if there's anything else. Yeah, and that's it for the moment. Just take a quick look. There's good documentation for these ones. So for the web, yeah, so the web one uses React and TensorFlow, yes. And the Python one, just sample code that you can do to load an image and predict with your model. And you can see the different backend for TensorFlow and TensorFlow Lite. So you can see sample code here on what you need to do to prepare your images for to pass them through the model, and the code that you need to predict and get a prediction out of a TensorFlow Lite model, or TensorFlow in the other case. Right, we're close to getting this downloaded. And while we're downloading, I'm going to try and prepare a small data set. So let's see what we can train for. Well, the first thing I'm gonna do, because I have a fairly consistent data set here, I'm just gonna download all of these images from here. So we'll start with that as one class. Let me actually connect my iPad. If we can. Can we do this? Nope. All right, so I have my iPad here, and I need to, okay, I have an adapter here. Okay, let's see if we can plug the iPad here. Hello? Do we have sound now? All right, so one second. All right, so I'm trying here, well, first to see what's taking the most of my computer, because the fan is sounding a lot. Let's close a few things. Okay. Well, we got Lobe. I'm gonna use it here. I like that new icon. Oh. Right. Okay, let's see if I can get my iPad screen here. Right. Okay. Well, it seems we have the iPad here. So if I do that, okay, so we're live. Okay, so we have two different apps that we're gonna be looking at, and I'm just gonna try to explain what they're gonna do for us. So first we have Lobe. That was released on Monday, October 26, 2020. So Lobe has been in development for the past 4 years. So it's been in development for 4 years. The 2 first years, it was something that the team developed on their own, and then half term it was acquired by Microsoft, and then today is open for anyone who wants to use it. So Lobe is an application that you have. Let's just switch this to, let's leave it as it was. So we have an app that is literally a canvas where we can have like our images, and then we can drag and drop, and by drag and dropping, Lobe will assign each of our images one category. So let's say we have this image, and then we have this image. So we'll define two categories. In this is like, let's say that blue landscape and red landscape, and then we'll take and say to Lobe, okay, this image belongs to the blue category and this one to the red one, right? So at the end of the day, we'll have in Lobe what we're going to try to do today. So for instance, and we need to define our categories or our labels. We're going to have a set of image types. And those are going to be our tags. And what we're going to do is put a lot of images in each of these categories. And then let Lobe, Lobe is going to train a model for us. So what does it mean to train a model? So once you have a lot of images, let's imagine that each of your images belongs to one of those categories. So it's good just to add one color to each of them. So we have a bunch of images, right? So this is our real data. So these are images in our computer that might come from your phone, from Photoshop, from your computer, and they might be in formats such as JPEG or PNG or other things. And these images, you're just going to tell Lobe what category they belong to. So Lobe is going to go into the training process, and on the background, it's going to train a neural network, right? Which, I'm not going to do properly, and at the end of the day, that neural network is going to learn and is going to be able to tell you if your new input, so the thing that you put here, is one of these three categories. So in this case, would be sketch, photo, or color sketch. So that's what we're going to be doing. And once that gets done, Lobe is going to allow us to go into play mode. So this means that we're going to be able to feed a new image. And we had this concept of a neural network that there's a bunch of operations happening here. And then there were two possibilities for the three different colors. So what the neural network is going to do is going to put this thing here, is going to do a bunch of operation to those images, and then hopefully it's going to get to this path and say, okay, this image that you input here on the left belongs to the sketches category, right? So this is what's called a classification problem. And one of the most famous neural networks that has been created for that is ResNet. Was developed in-house by Microsoft and is used in many classification algorithms nowadays. And more recently, there is one called EfficientNet that is for image classification, and then another one that is called EfficientNet, that is an object detection network that uses EfficientNet inside for feature extraction. So let's just evaluate again. So we have an input image, And in this case, the task, let's say, our image could be that, or it could be this one. So here, the first thing what we're gonna do with Lobe is gonna tell us whether it belongs to one of the three classes. Another thing could be, a network that allows us to identify things like mountains or trees in an image. So for example, if we had an image like this, maybe with a car and trees, right? So the network would be able to say, okay, this is a tree, this is another tree, right? Maybe even saying this is a car, and this is object detection. All right, so let's keep going. So once we have, if we go back to what I was talking about before, so we have Lobe, and it's going to classify images in 4 or 3 or how many categories we create. After it's trained, we said we're going to be able to play with the model and supply it with new images, but we're also going to be able to export TensorFlow file, and that TensorFlow file we're going to be able to use in our apps. So it's going to be something that we can, and it's TensorFlow or TensorFlow, what's called TensorFlow Lite, TFLite. These are 2 different formats, and they can serve for different things. But usually, if you're going to deploy to a device like an iPhone, an iPad, or other, or even to the web, you want to use the TFLite model. These you can use on a website. So you could have a model that classifies images that people drag and drop from their desktops. You could also use these models on your cell phone. So you could say, okay, classify whether this is one of the other category, and you can use it in other desktop applications and thing, let's say in Python or Windows. So you have an app here, and it's also trying to say for a set of images what they are. Or another thing you could do is you could do an application that is recording or taking frames from your webcam, and at each moment telling you whether it's 1, 2, or 3, right? Each of these categories. All right, so let's get started. Let's go back to Lobe. Let's see how that works, and let's switch this off for now, or let's leave. Well, let's take it off. All right, so I have here some models that I tried training before in the previous versions of Lobe during the beta, but we're gonna create a new project today. So as you saw, I just opened Lobe and created a new project, and we're gonna call this Live 4. So we have so this application, or this app that is called Lobe, that has these 3 different sections. So label, to start training your model, import and label some images. You can go to learn more to read some of the documentation. It's really nice documentation that you get with the application. Many common frequently asked questions. A watch tour, so there is like a guided tour or video that you can see if you open that link. You can see, I think, Jake here with his sample project of how to train an application to gather stats of whether he's drinking enough water or not. using the webcam on his computer. Let's see.
Hey, I'm Jake. We created Lobe. Lobe is an easy-to-use app that has...
Yeah, you can go watch that. And, after that, you get the training progress. Your model will start training by itself, and then you can play with it. Okay, so let's see. So the first thing I'm going to do, I'm going to just get images from the camera. Not that camera. So let's see if I can get my other camera. I'm not sure how to do that. Okay, so we need, let's see. All right, so it seems I can't really do that right now. Hi, Jim Mark. Thanks for your message. I'm glad that that you're online, and yeah, feel free to just drop and watch it later. You can also join the Discord channel that I just created. Let me just share the link. Juan Marco. Is the audio good now? I'm glad that that you're online, and yeah, feel free to just drop and watch it later. Okay, so let's see. How can we do this? I'm gonna take screenshots maybe. Haha. Okay. So can you stay today, or you're gonna try it some other time afterwards? Right. So I'm gonna take some screenshots here of the screen with me looking down. So while I do this, let me just let's see. So I'm gonna make sure that that the screen is empty, so there is no noise here. All right, that's a problem. So just so you know, what I'm trying to do now is just to build a really dummy or simple data set. Let me just see. All right. So I'm taking snapshots of my head when I'm looking down. And now we're gonna make a folder for that. Right. Looking down. And now right. So these are all looking up. It's looking down, looking front. Right, so we'll review now that yeah, I think it was I also recorded a video without meaning to, but there it is. And okay, so let's see all of the photos we took. So these are all, there is that line there, that blue line, which is not going to be great. And then there's these images that don't have the line, except for this one. So we're going to open Photoshop and remove that because we don't want it to be getting confused. Let's see how we're going to do this now. All right, I'm gonna try, because I can, I can put myself here. So this is what we're gonna try to input to Lobe. So is the program is gonna see me like this, and hopefully it's going to be able to classify whether I'm looking down or looking up. But yeah, let's come back here. So we wanna open this. Well, maybe, yeah, I don't know if that line is gonna be a big enough feature. So what's happening here is that I'm afraid that I don't want the network to learn how to classify that there is a line here, because then instead of classifying that I'm looking up and down, it would be classifying that there is a line or not on the image, and that would not be what we want to do. Yeah, and one thing that is not a great idea is, so let's see if the line is in the same place everywhere. Yeah, so I'm gonna make a quick action. So just gonna make a quick action, remove blue line, and we're just going to do this. Thinking that might be easier just to take new pictures, but and then I save and I close it. Right. Okay. All right, great. So now we have these two, our data set. So data set is this blue still? Okay. Right, so now we have the data set, all these images. This one, I'm looking down, but you can see my eye, so maybe looking to the front. I'm not sure if it will be able to differentiate. Let's just leave it. Well, let's actually put them there. I'm actually looking down, but maybe, yeah, maybe we just want face up or face down for now. All right, so this is our data set. So we have two different categories. One is Nono with head down, Nono with head up. So I'm going to now in label, so I'm going to import and label some images. Let me see if I can just drag and drop the two folders. So square, 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 cancel. All right, so we're gonna do face down, face front. So, you know, we could individually get one of these images and drop here. So it will ask us like my category, right? So you just create a category that way. But I'm gonna remove that. And if you just get your folders properly named with their, you know, the contents that you wanna have as labels or as label data, face down and face front, just name them. And now we drag and drop our images directly and then use the label using folder name. Import. So what you can see here is I think it's impressive. So let's just talk about this quickly. So what we have here is that Lobe is now training. You can see it right here. So Lobe is training, and that means that it's training a neural network on the background without having to write any code at all. And it's going to, you know, the neural network is going to use our 42 images, 22 for face down and 20 for front. And it's going to create a program, a neural network, that knows how to recognize whether the face is down or the face is up for a new image that we input. So here we can browse through our data set, right? And, you know, I named it face front, but this is actually face side or something. So that's something we can add new labels later. So this is training right now, and I can see, let me just check that the stream is not slowing down because we're training locally. Okay, I'm gonna take myself out of the equation for a moment. So what's happening here is that my machine, this is a MacBook Pro 15 inches. My machine is training the model using the CPU of this computer. And that actually takes a lot of computation or computer power. So the computer has to think a lot and is actually making the the computer lags. So that sound, if you heard it, means that the training is done. So maybe if I show up here again, maybe the computer won't be too slow. Hello. Let's see. Has to think a lot. And okay, so we have our model here. Let's just put these things here. So we have this Lobe model that we've trained. We have two different labels, and you know, when it says train, face front 50% are classified correctly only. And you know, this might be because there is something that I think everything is getting labeled as face down. These images are probably way too similar, or I moved a lot, and there are patterns on this data that the neural network is not recognizing properly. So let's see from face front which ones did it. So it classifies everything as face down, right? Yeah, everything that's classified as face down is good. Everything in face front is not good. All right, so this means, you know, the data here, we might have things that are not properly labeled, or the model might be learning from features that we didn't really intend it to learn. So we're gonna go and do another experiment. It's a new project. Experiment 2. All right. So I see some new people get connected. Hi, if you want to say hi in the chat. And if you can hear us properly. Right. Let's see. So what I talked about before, so we have a few windows open here, and maybe that's also why our laptop is going a bit slow. Let me just close. So that's here. And new window. All right, so I'm gonna go here, a really quick thing. So we're gonna get all the all of these images I'm just gonna download. And right now, you know, I don't have any prepared data set, and things might fail because you never know what exactly is going to work. All right, so let's look for so right now I'm scraping data, right? This is my own website, but I'm trying to download this data and put it on a folder, so we use it as a training set for Lobe. All right, so we look for the image that's called lazy. Yeah, I think I already did this, right? So lazy, yes. Images is not defined. Let images. Okay, images. Right. Okay, so we have all this. I have used to Google version of Lobe a few months ago. Pretty interesting stuff, very user friendly. Nice. Yeah, it's changed a bit from what they had on the website initially, but it's still really nice to be able to train a neural network without having to write any code. All right, so we have this, and we're gonna use, just gonna quickly I'm just going to quickly open a new Visual Studio Code file, and we're just gonna quickly scrape all that data and download it. Right. Right, so yeah, if we open any of these images, so I just go and open the URL, I can see that doesn't exist. Okay, I need to do something else. So JSON stringify images. Okay, this is what I wanted. Right. Okay, so now we get one of these URLs. That should work. Yeah, we got the image. And what I'm gonna do, I'm just gonna download this. I don't know if this is, let's see if this works. So if we go to the desktop, make a new directory with the sketches, and we run this code. So we're downloading an image with curl. For those of you who are not familiar with it, that's, hey, Mayur, how's it going? Nice to see you around. Can you hear me okay? Everything good? Image, sound? Okay, let's see. So I need to, well, first, let me just copy this and leave this as it was. I'm just gonna make this. Okay. Right, so let's see. Right. Okay. Yeah, so what I've done right now is just write a command that if we have the URL of an image, we can download it, right? What we're gonna do now to automate everything, so the download of all the pictures, we're gonna reduce the size of this picture that we're downloading to 400 pixels, so it's a bit smaller. We don't really need a lot more for this to work. And so let's say 400. So here there's an argument that says width. We're going to change it to 400. I'm using here a service called imgix that serves your images and lets you compress the quality and reduce the size. So maybe even reduce the quality a bit. So size is a bit smaller, everything's a bit faster. So we're going to go here, and the first thing we're going to do, we're going to select every single line and download the images with their real name. Actually, we gotta do it this way. So we copy that argument, and now we do curl that, we add quotes, and then we say the output is going to be an image with the same name. So I now have built this set of commands that I can copy and paste here. And as I paste, I press enter, and this is now going to start, hopefully, downloading all the images. Yeah, to this directory. So as you can see, we're building a data set with, well, just downloading those images that we're going to use as a data set to train a neural network to classify the drawings with Lobe. And we're going to see, just try to see if it can learn any patterns from what these things are. So it's probably not that easy, but let's see if it learns something. So the first thing I'm going to do, I'm just going to create 2 folders. So black and white and color. And now we're just going to open the 2 and divide these images. So right. So these are black and white, and at the process, so at the moment, what I'm doing is I'm labeling this data set. So we have data, we have what's the ground truth. These are images that are unlabeled, so this is just data. And as I move them into a folder, I'm actually labeling them and labeling the data set into a labeled data set that we can use for training. And if we use it for training, we can call this a training set. So let's just label everything. And this is a really manual process, and this is exactly what we would like the neural network to do for us, to be able to classify the drawings in the ones that have color and the ones that don't. Is arguably an easy task for the human eye, but for a program, you would have to write a lot of stuff. So is this, for instance, this color? This is actually sort of black and white, a bit of brown tones. And okay, so we get here, there, right. So we're labeling. It's the first time we label a data set. Right. Whew, get in there. Get in there. All right, something really important here. So let's see. If I get my stats, there's 36 items on the color one, 34 items on the black and white. It's pretty leveled. And I don't really know how to do this, but we do need some test set, right? So this is our training set, but we don't have more images to test with. So if we train it, we will never know if it works or not, because we haven't really tested it out. So I'm gonna get 1 random images, 2, 3, 4, right? So I'm gonna keep 4 from here to test. So I'm gonna do here a color test folder and a black and white test folder. And we're not gonna use, these images we're not gonna use for training, and these ones randomly as well. Actually, yeah, okay. And this one. So black and white test, there are 5. Let's see, this one might be confusing. Let's just leave it here. So we have 4 test images for each of the two data sets, and we have our data set built, right? So this is our data set of black and white and color sketches. So now what we're gonna do, we're gonna drop the color and black and white folders. So right now what I'm gonna do, so before we do this, what's gonna happen right now is that my computer is going to slow down a bit, because I'm gonna drag and drop the black and white and the color test folder into Lobe, and Lobe is gonna start training a machine learning model. And my computer doesn't have a GPU, and its CPU is going to have to do the heavy lifting and the most of the part of the job that happens here. So what do you think? Do you think the model is gonna train properly? Do you think it's gonna learn how to differentiate between black and white and color pictures? What I'm gonna do right now, I'm gonna stay here, but I'm going to hide myself, because there's gonna be maybe some lag on the speed at which the image is shown. Let's see where OBS is at. So goodbye. All right, and let's drop this too. Again, same as before, we're just gonna say use folder names to label your images, label using folder name, and click import. This is actually Panagiotis Michalatos, and these are some of the hand sketches that I've done over the past years, and you can see that Lobe already classified them or labeled them properly. So it didn't classify it yet, but it labeled them properly just using the name of the folder. And what we can see here, experiment 2. So we have 62 images, 30 are black and white, 32 are color, and this is training. There are, this is what you can do easily, so you don't have to do a lot of work for labeling or something. You just get the images you have and start training a model. But what happens there is that usually when you see models that perform really well are not trained with dozens or hundreds of images, but thousands. Sometimes like there are millions of pieces of information that are used to train a machine learning model, and that's what makes them start working better and better and better. So I don't really have high expectations of this model. I don't really think it's going to work that well, but maybe we get surprised and suddenly this works really well. So as you can see, if I open this, these are pretty low res sketches. So these are not high resolution images, even though we could have obtained high resolution images. I think this might make it faster because all right. I love that sound. I went through and tagged a bunch manually at first. The folder tagging is amazing. Yeah, 60-second Revit. I just discovered that today. I think I had seen that before, but yeah, maybe I should have said that before. So I just realized that today. I hadn't used that before either. And just having them in the folder, you don't even have to touch. So, for people who are trying Lobe, if you go here, you can change a label. You can label manually. And if you go to the other view, you can even, you could type here. So you could color gray or something. You could make up new labels as you go. All right, so well, 60-second Revit. I haven't asked. Where are you connecting from? All right, so these images here have been labeled as color. Interestingly enough, those are wrong. And color, so everything that is color has been labeled as color. All right, so there is more information that the model has learned about the color ones than the black and white. But before we go and try to fix this, let's go and play. All right, I don't want to play with the webcam because, well, let me see, can I? Yeah, it doesn't really let me do anything here. So what we're gonna do is play with your model, drag and drop, or import. So we're gonna minimize this. We're gonna open our sketches folder. I'm just gonna stay here. Put Lobe to the side. All right, let's see Lobe. So black and white test. So Lobe already does some validation internally to see what's failing, but let's see how it works with this one. Color, that's wrong. Yeah, I don't wanna add these images. I'm based in the US. Well, hello from the US. I tried to do the live stream a bit later today to accommodate a bit with the time for people in the US, because I know in Spain I usually do it a bit earlier. I'll encourage you to, let me just send the, I'll encourage you to send the, for you to join the, oh, no. How can I do this? So to join the Discord channel that we're just started, and maybe there we'll coordinate a bit for future live streams and videos and other things we can connect. All right, so let's do one thing. I'm just going to drop all the images here, so all the folders with the images I want for Lobe to label. And what is this doing? So anyone watching the video right now, have you been able to train Lobe? What results did you obtain? How much data have you used? Did you use many images? Did you use just a few? Right. Okay, and same thing. I don't know how fast my computer goes to stream while I'm doing these things with Lobe, so I'm gonna hide myself for a bit, but I'm still here. Right, this doesn't seem like it's working. All right, let's just drag and drop images here. Okay, this is wrong, definitely wrong. This one is black and white, that's good. Yeah, there's something also with the canvases, so yeah, I don't know what to do with the canvas. Right, seems like it trains as I drag and drop images. Color, yes. Okay, what are these? Color, nice. Yeah, it seems like it's classifying the color one pretty well. Oh, nope. Right, let's see what we can do. Okay, so what I'm gonna do now is I'm gonna copy this folder and do data augmentation. So after seeing your tweet, I trained a pumpkin classifier for normal pumpkins versus carved pumpkins, about 30 of each image. How did that work? Feel free to share the results on the Discord channel if you want me to show them or something. And okay, so it finished training again. So it seems like now the black and white starting to classify a bit better. You know, the color are still like, some of them are misclassified. Black and white, and this one just classified that one wrong. Right. So let's just make an action here and in Photoshop. Like, I know we could probably do it in better ways, but I'm just gonna make a function that rotates the image in Photoshop and saves it. And that way, you know, we'll have the same images, but we'll rotate them. I'm not sure, that's something that we'll have to see, but Lobe might be already doing some data augmentation when you don't have many images. It might be doing some data augmentation. So yeah, not sure what to do there. So I'm gonna, let's actually, instead of doing that's a technique that we could do, but let's just see black and white extra. So we're gonna gather some more drawings from things that I have in here, so on my machine. So let's see, we have that sketch. All right, so I'm just trying to download some other images that I have here on my computer that might be good for us to add to the training set. One thing that is a bit odd is that images are actually, and this is something that they say on the docs, that images are actually, your Lobe is confusing this image. Yeah, so images are, in our dataset, have different proportions, so their canvases are different, and that might be getting the model confused. So I might actually just try to reframe them all. All right, so we have here, we have an image, and I'm going to convert the so geometry, we already have a 400, so we can say that we want the background to be white, gravity. I'm using Image Magic right now for those who are not familiar, which is going to try to automate how we resize extends. Let's see. Extend. Right. Yeah. So. See. That work. Okay. Yeah, that worked. So what we've done is automate the resizing of the image, which we're losing some quality, I can see. Not sure why. But, you know, whatever. All right, so let's do one thing. So now we're going to say, so this is sketches v1, and we're gonna make sketches v1.1, which is squared. And I'm just gonna run this same command in all the folders. So you can see these are all going to turn into square images. Okay. So I'm gonna go into this one, run the same. Okay, we remove the originals. Yeah, we actually could just make a, well, whatever. Right. Okay, so we should have the same amount of images, and we're going to close this experiment, so no need to do it in Photoshop. And a new project. So again, so this is experiment 2.1, and we're gonna do the same thing. So just drag the black and white and the color. This is going to use the folder names as labels. And again, well, this is a lot more organized now. So this is going to start training again, same amount of images, and I'm going to hide myself once more just to make sure that I'm not making the computer go really, really slow. Okay, it seems to be training. See, so the quality of the images when we zoom in is not great, but to see them small, you know, the neural network should have enough information to know what we're looking for. And once again, we're just waiting for that sound that tells us that the training is done. Okay. Right, so I usually do this cheat sheet or like reminder to bring up things that I wanted to bring up so I don't forget. So previously we had I think it was live stream number 2. I coded, I just tried to do custom Python environments using Anaconda, right? So that video, if we go to this link, so to the main page and the training is done. So if we go to the main page of the channel, so we go to this video, so this cover custom Python environments, do TensorFlow slash. This is hello, it's Nana here. This is a crop of that. It's like a shorter, like a 10-minute version of how you can create custom environments with Anaconda and Python to use multiple versions of TensorFlow on the same machine at the same time. And if you go to the video description, you'll see here that we have a cheat sheet, and the cheat sheet shows the commands that you have to run to do what I did, right? That's a summary. The too long didn't read, but if you want more detail, you can go on and watch the video. And the other goodie, the other thing that I also discovered that is super handy is this Conda sheet that I'll put on the Discord channel right now. So let me just go to so you guys see what the Discord channel is. Right now I just have the TypeScript getting simple and parameter camp, and I'm not sure where this will end up, but let's just do a live stream channel. Let's see, can you edit channel? Yeah, so all right, so in this channel, I'm just gonna, we can talk about when live streams are gonna be or other things, but for now, and we're just gonna paste this here. Can you make links here? this episode. Right. Good. Okay, so let's see what Lobe did. The background. Wow, this is a lot better. So this actually trains. This is a success, I think. So this means the different canvases of the drawings were affecting how the no, actually, okay, I that was just the labels. All right, so it seems like it still doesn't learn properly from what we wanted to learn. It's misclassifying a lot as the wrong label. All right, so let's close these things. Let's go to the test folder again. Nope. Okay. All right, so let's see from what I understand. So this is training again. I'm gonna hide myself once more. And what I was trying to get at before was trying to look for more sketches that I had that we could add to the black and white label. Okay, so I gotta start the syncing of Dropbox. Right, this is also black and white, but it's really bad. Well, I have here some other images that might be helpful for the black, so for the color section. Yep. Okay, so we have web images here. That's gonna be all of these images. We're gonna drag them and into the, so another thing we can do, we can click on the color label, I believe, and drag new images. Hopefully, oh no. Well, another thing, you can go here, select them all, and select color, and that's it. And then again, this starts training once more. All right, so I don't know that we can do a lot more today to improve the results of the training that much. I mean, we'll have to have a bigger data set or adjust it in some way. But what we can do today is try to see what we will do with the model and where would we take it, and how would we use it. One of those places where we could use it is Runway ML. We're probably not gonna have time today to expose the model in Runway and get it working, but you know, we're gonna see. All right, so this is getting better. So now we have 91% and 96%. So again, we need to get a new image and we need to test it. So we need to see how well it performs on images it has never seen before. So again, so these are square images. So if we get a new image, we're going to watch photos, and I want to do that convert command once more. Oh, nice. Well, that's one thing we could do to augment the dataset, but that's not really what we want to do. So what we're going to do is that we're going to set the geometry to 400 by whatever. Right, that's not possible. So okay. Right, so we have the images. Let's see what it does. Some of them have texture. So what I'm gonna do here is that I'm gonna just try. So for instance, what happens with this one? Black and white, good. It's good. We could add it to the dataset, but before doing that, let's just classify the others. Okay, black and white. What about this one? Oh, color. Nice. This is working a bit better. So just the fact that, well, the tag is actually here. So just the fact that we see here that is color, and that's actually what we intended it to be, is pretty good. And it's not, yeah, and this is the squared canvas color. Nice. Well, this is starting to work a bit better. And this is just because we added more images. Like we have now, what do we have? So 51 color images and 34 that are black and white. Let's see if we have some more. Well, let's go actually to the web. So something that is not on my machine, and we might be able to play with as well. So yeah, maybe sketches. So if we had drawings like these ones, what would happen? How do you classify this one? Yeah, black and white, which is good. And what about this one? Color. Nice. This is performing pretty well. So it seems like the Lobe finally learned how to do the task that we want. You know, I'm not adding these images. This is Lee Steele. I know her from Australia and Sydney. Black and white, that's wrong. So it's learning something that I don't know what it is, but it's learning something about the line or the type of canvas or something that doesn't have to do with the color. And one more in black and white. Black and white. All right, more or less it works. What do you think? Good? Bad? What is it doing? All right, so now that we have this here, we haven't used these ones for training either. Now we're gonna see what we can do with Lobe. So I'm just gonna move here once more to the right, and I want you to think about what we've done. So I want you to think about what we've done. We've trained a model with Lobe. by scraping images from the web. So in this case, it was my data set of black and white and color images. And we've just labeled them by putting them into folders, dragged and dropped them into Lobe, and Lobe already started training on the background. What this process has given us is a training set, so that we have here, that was used to classify, and then these 3 images were misclassified. It seems like those were the images that were. Let me see if I can go up. What is happening here with the UI? Not sure what's going on there. Yeah, some on each category were misclassified, right? So this was classified as black and white, which is good. Wait. This is definitely not color. That's black and white. That's black and white. This is color. Yeah. All right. You see, having that misclassified image was because I labeled it wrong. So we can now go to the color images. Let's go to the label page again. You see, this is misleading because there are parts of the drawings that are black and white in the colored images. That's really misleading. And this is black and white. But because of the nature of the background of the paper, it might get classified as color, because most of the papers that have that texture are color sketches. And this is actually more like black and white, I would say. Yeah, maybe we can call this black and white. It's going to classify wrong. Okay, let's see what's classified wrong now. Yeah, this is, I mean, this has watercolor. All right. Yeah, so let's just leave it so it finishes, and we'll try to export the model. Okay. All right. So as I was saying before, we trained the model, and it works at a 90% accuracy, more or less. So it gets 5% of the images incorrectly. But what you can do now is, well, you could play, so we could show things on the camera, but the data set is not from the webcam, so it's not gonna work perfectly. We click on improve your result by training models. It can take longer to complete. Do we want to do this? I'm not sure we want to do this right now. We'll try this some other time. So what we're gonna do right now is that we're gonna go here. So you go to your menu. You have the preferences, updates, about Lobe. Well, let's open the about Lobe. What does it say? Notice, privacy, license, version, still in beta. All right, so we go again here to our file menu and then click on export. So if we go here, we can see we can export to Core ML to use in iOS and macOS apps. You can use in TensorFlow for cross-platform apps, use for mobile apps, TensorFlow Lite, or local API, used to host your model locally. Well, first let's try this out. Let's see if it works. Host your model on your computer, prepare request. Right, let's see if that works. So apparently in that URL there, I can go, and this model is telling us that we have one input that is an image, that is a B64 shape null, and I can provide that like this, and then we'll get a confidence for black and white and a confidence for label and the prediction here. So that's the first thing we're gonna do. So just gonna leave this here on the side, and I'm gonna go, just gonna go look for something here, and we're gonna create a new, let me do one thing. Let me actually go to the live repository. So what do we have here? Because last time I haven't been doing a good job in committing the code here. So live 4, and this was from live 1, but it's really dirty, so I'm not gonna, probably not gonna commit that. Well, maybe we commit something, I don't know. I need to clean that up. So live 4, we're gonna go there. So in today's folder, we're gonna make a new app that is gonna be Lobe request, and it's empty at the moment, but I'm going to copy some code that I have here. To not start from scratch. So I'm going to create a package.json, create a package log.json. This is a really weird way of creating an app, but that's what we get today. And then we're gonna get a index.ts. So for the package, so we're now I'm gonna open this folder with Visual Studio Code with using code dot. And I'm going to add here Lobe request. Right. So we're just gonna write a simple TypeScript program that requests an image from Lobe, a prediction from Lobe. So what do we do here? Right. Okay, so first thing I have in this app that I'm using as a base template, I have TypeScript, Node, TypeScript, and Super Agent to make requests. If you're not familiar with Node, TypeScript, and stuff, don't worry. We're just going to write some code in TypeScript that is going to let us make a post request. So that's like a web request to the Lobe endpoint that we've created, and that's, you know, that's just like an application that is serving how can I say, so Lobe is creating an HTTP server. So Lobe is actually right now serving an HTTP server, and from any language you can make a request. For example, in Java or in JavaScript, so you can make a request and get the results. So right now I'm just looking at the JSON here because we're just gonna write in TypeScript and do that. So the first thing we'll do is just import the request from Super Agent, and if I do here, this works. I can come to my terminal and then do, we can actually just do this. So we just run tsnode.index, index ts, and run that, and we'll see. This works. See, this is the output of the program. So the program is running, and now the only thing, so show some fail. So I'm just gonna disable SonarLint because it's giving us some problems. Okay, let's see once again. Okay, for the ones that are online, how's this looking? Are you following? Are you able to follow? Are you lost? Do you think this is interesting? Do you have any feedback? All right, so I'm going here, I'm gonna make, let's just hide this and make this bigger so you can see it. Not this big. Okay, so we have here request now, that is our super agent library, and we're going to write here get our URL that, you know, we have to define our URL from Lobe. We're just going to get that from Lobe here, not this, but just that. And we're going to make a request that's going to be, well, actually not a get request. We're going to have to do a post request. We're going to tell it to accept a JSON payload, and then to do something. So this is going to be the response body, what we want to see. Okay, and for the data, let's see, how do we set the data? I want to set the payload. Okay, so we send the payload here, and our payload is going to be with the form that Lobe is telling us as JSON, and we're going to have here a base64 image. It doesn't exist, but it will. Right. Okay, how do we get a base64 image? So the first thing we can do is go to our dataset, go to, for example, our watch or watches, and here we write the command base64 on Mac. I just, you know, drag and drop this black and white image, and it gives me the, let's just see the whole thing if we can. I don't think we can, but yeah. This is the base64 encoding of this image here, that one. And, you know, I can write the same command with a slight variation, so I can do this and then at the end do pb copy. At least this works on Mac. Just with one slash, and that copies it to my clipboard. So I do that, and then this variable contains the image as base64. Hopefully that is gonna work. So now what we do, we open our console. So we have a program that defines the URL, the base64 image, the payload with the inputs that we have just one input that is called image, and then we request to that URL, setting it to accept a JSON payload, sending the payload, and then on request successful, we're gonna process that, and we're gonna catch the error. I think the error had the message property, but I'm just gonna log the error if an error happens. And now let's see. So this is a good moment, and we're going to run ts node index.ts to execute this program. If it works the first time, oh, it did. All right, this is pretty cool. So we got the output labels and the predictions. So it told us that the image is black and white. So, you know, we can now, let's say, well, the first thing, we have the response body here, but we're not able to see in detail the labels. So what we're gonna do is that we're going to log the res body outputs labels just to try that, and then the prediction. Execute again. So that runs, takes a bit. I don't know what part of the code takes longer, but you know, we're getting a confidence of 73 or 74%, and then 26 is color, but it's black and white. This means now we could use this model for other endeavors just here with code. So we could have a program that from time to time is looking for images and classifying them. So just to make a quick test, how can we do this? All right, so what I'm gonna do, I'm gonna go to something that we're gonna take a look at afterwards. So I'm going to open this up. And I don't know, for instance, I'm just gonna draw here something, and I'm gonna save this as an image. I'm gonna open this image, and we're gonna save it. We're gonna get the base64 for this one. So base64 for this image to the clipboard. And now we just come to our program, and well, we want to do that. Comment that out, and now we're going to run the program, and it's going to be running for the second image that we've stringified or converted to base64. Right, so this is black and white completely, and really small percentage of possibility for color. I'm not really sure why it did that, but yeah, something there. I mean, we were probably a bit lucky. Okay, let's go back to that one. All right, so what else can we do? So we have the code, and I'm gonna do this before I forget. So I'm going to, we'll comment out this code. I don't know how big this image is, so it's gonna go to cloud there, 60 KB. It's okay. So that is base64 image of black and white watch. So we're just gonna put that in here. So what we do here, define our Lobe HTTP server URL. For this, we have to go into file export local API. File export local API. This is load super agent library as request. Define an input image serialized as base64 on Mac OS. You can do that on the command line with base64 path to image and then pvcopy, which copies to your clipboard. And then the payload, define payload matching the JSON schema that shows up on the local API Lobe menu, and then make a post request to our local API server with the input image payload. And then, you know, on success, print confidences, so label confidences, print prediction, output label, output prediction, error, print error message. Okay, so this is the code. I'm going to just put here post request to a local API HTTP server. Right. Yeah, that sounds good. And I'm gonna commit that, so problem. So right now the problem I have is that I don't have a git ignore, and I've added all my node models to commit to git, which is a beginner's mistake. This is why there's 652. Right, let's delete this. Let's move this folder out. Let's fix this. All right. All right, so let's remove these two as well. Or license. I deleted license. Why did I delete license? All right, let's go. Well, hello. I want to say hi if there's somebody there. I see there's some people connected. All right. So now we have a git ignore file. It's going to verify that that's actually working. npm install. All right. No such file. Okay, we're gonna go load request npm install. Okay, and now we just need to see if, say, we do git at all. All right, this is good. So now we can commit. So we can say add. So this is like 4 add lobe local API request. And then we push. So pushing. That should be now live. Right, so you can navigate that code now. And you know, little detail, if you copy the base64 string, you can go to any base64 decoder. You can also do this locally with any programming language or on your Mac. You can decode the base64 image string to an actual PNG. So you can have that here, right? And that you actually just do that by prepending this. So any base64 image you have to add data, colon, the format, in this case image slash PNG, and then semicolon base64 comma, and then the base64 string. All right. Good. So you can go now. You can go here. I'll put this on the Discord channel as well. And all right, so where were we? Well, first I need to recover all the other live files that I have here. I'm gonna close a lot of stuff. Right, still have Lobe here. Keep that open. We're gonna close all this stuff. We have our data set here. Maybe we need to put the data set somewhere as well. All right. So now that we have got to here, so I'm gonna close a few things. Well, let's take a look at the Notion file. So this is some homework that I did, that I installed Runway and the Pix2Pix model, because last week I didn't have it. And we've seen the conda cheat sheet. We've seen that we released this video. We haven't done this. We have set up Lobe, and I have Runway, but we have to go there. We have to watch it, how to do it. It's a code challenge we might do. So I'm going to demo the Pix2Pix glitch app. So let's do that right now. So that just take a few seconds there. So, okay, let me recap a bit. So we have this model here that we've trained with this data set with Lobe on my machine. And we were looking at the export pan. So if I if I click here, so let's say we click on TensorFlow Lite, I'm gonna save to the desktop. And optimize and export. No, so we're just gonna export. Optimize is when you want to have better qualities or better performing model, and you don't mind waiting. You just want it to perform really well. But now all we want to do is just try it. So we just want to try the model and see what we can do with the TensorFlow Lite model version. I'm just trying this one. We could also try TensorFlow, the normal TensorFlow, or Core ML for iPhone. But let's just try TensorFlow. I just want to show you what happens when you do an export from here. And I'll just wait for a few seconds while this is exporting. I'll go get some water. Okay, let's see. So we have exported the model. So now we're gonna play with it. So I'm just gonna close Lobe completely. Close also Notion. And we're gonna also close these things. All right. Well, hello. I see that there's some new people connected. So if you want to introduce yourself or let me know where you're connecting from today. We're testing now here. So we have exported TensorFlow Lite model from Lobe AI from the desktop application. And we have some files here that I'm going to open with Visual Studio Code. So I'm going to open that folder that has been generated by Lobe on my computer. So we have the signature.json. So if this is automatically exported, but we can format it to visualize it a bit better. And let me just change sides, and I'm still on the good side. So experiment 2.1, this is the doc name, this is the project that we've exported, this is the version, is probably a unique identifier for the version of the document and for the document ID. The format is TFLite version 8. And we have the signature of the input. So as we saw before, we needed to send an object that looked like this one. So this is a good way to know what input parameter we need to use to build that payload that we were building before. So, you know, just to give you some reference there, we have coded this little application. Let me just put it here to the side. So if I look in here, when we build the payload in inputs, we actually had to use this format. So you see here it says inputs, image, dtype, shape, whatever. This is actually the input type of the model. Here was a JSON payload that we were building for the local API. This is for the TensorFlow Lite model. Here, instead of being a base 64 image, the input type is a tensor, which shape is null, which means it accepts a batch, a series of images, and then 224 by 224, and then 3. This means, I think, I always mess it up, but I think this is a height by width by RGB colors, right? So an image could be 224 pixels by 224 pixels, and maybe each of the channels can contain a color, right? All right, the name is image, and that's what it says here. And then when we input something of this shape with this name on the model to the input named image, we get this output, right? The prediction, which is a string, which will be, the shape is null because it's a string, and it will be one of the labels of our models that are here. So the classes, the label are black and white or color, and the confidences will get shape null and then 2, which means we'll get an array of one of these labels and then a number, which is, well, here it says 2, which is 2 numbers. Let's see what we were getting. What were we getting before? So we might be getting confused. So if I open Lobe again and I go to our live project and we do ts node index.ts. Right now it's not gonna work because there's no Lobe model running, right? So it gives us an error. So we printed the error, something we didn't try before. So we're gonna go to experiment 2 and we're gonna tell it to work as a local API, and that should be now working. Yeah, all right. Well, I mean, in this API it just gives us one float and the string and then the string of predictions, but yeah, I'm not sure what that stands for. So that's the signature. The save model, the TFLite, this is a TensorFlow Lite model, which is the model itself that we're gonna see how big it is. So it is 104 model, 104.6 megabytes, and then the example. So the example is, there. Well, here I'm gonna show something really cool. So if we go I can do glow sample readme, and we can get a rendered markdown here on the command line. So there are 2 key elements in the main export directory. Your model in TFLite, but let's actually read this. It's a human, not as a robot. Okay, so here there are 2 key elements in the main export directory. Your model in TFLite format and signature, which contain information about your Lobe project. With this, you're ready to use your model. If you want to see an example of how to use this model, there are instructions below for running quick test script. Example contents, blah, blah, blah. Simple script to quickly test your exported model. Run example, you will need Python 3.6. This shows you how to create a virtual environment. Source it, Python, pip requirements. And the TensorFlow Lite runtime for 3.6. Finally run the example and see. We're going to maybe leave this aside. Maybe I don't know why they chose Python 3.6, but I know that I might already have an environment so to run this. So we have a TFLite environment. Let's see if we can Python TFLite path to image for testing. So we have here our data set. So our image for testing is going to be the black and white test. Maybe, yeah, some of these for instance. So let's just try to quickly see if we can run it. So we have the example, and well, let's see if that's properly set. Yeah, so the signature and the model. So get file name. So signature has a file name. Yeah, save model TFLite. Okay, so this script has a pointer to the model. So let's just go to example and let's just try to do what they say. So conda activate TFLite. So I have my environment set up, TensorFlow Lite installed. My Python version is 3.8.6. Let's see if that works. And we're gonna do, so we had to run this command here. So Python TFLite example, and then the path to our image. That in this case is gonna be this one. No such file directory where to start. Okay, yeah, so same as always, I need to escape this path. And let's run that. No model name TFLite runtime. Let me do this. No model name. TFLite runtime. It is there. What are we doing wrong now? Python 3. Let me see. So okay. All right. So this is the problem. This is a problem with Conda that I haven't been able to completely figure out. So I'm inside here. So if I say which Python 3, but if I say which pip, so which IPyKernel, not found. So for now, I mean, we have a separate video on how to do these things, but for now, we're just gonna say this is Python 3.7.9, and inside of here, we should be able to do this. Okay, so that works. So what we're gonna do now is use that Python to run the command. So we're gonna run the TFLite example with our input image. Again, we gotta escape it. Could not find image file. Okay. Right. So we're gonna copy as path. Okay. Right, so that's pretty fast. So this actually worked. So now we have a Python command, right, that we can run to classify our images. Of course. All right, so let's do one thing. So I'm going to get, and this is sort of, well, let's get with the watch. So I'm gonna get the names of these files, and I'm gonna get the path of one of them, and I'm just gonna copy that. So I just want to make the full paths of all these images, and we're going to copy the command to make the inference call. Right, so right now we have all the right Python that has TensorFlow Lite, call that script, and then call for each of the images. So what you can see here now is that we run this, and now we get 1 confidence, 2nd, 3rd, 4, 5, 6. And we get every single image classified. This is classifying one by one. We could classify a stream of images continuously, so we don't need to, I can see that I'm in the middle of everything. So we can get this faster if we pass a batch of images instead of passing one by one. But with this, we've trained a classifier in TensorFlow Lite, and we can use it outside of Lobe in many different ways. This is even with Lobe completely closed, and here the gist of it, or the code, is they're getting the model directory. So that's the folder where the model lives, or at least the folder where we're running the script, and we're getting the model file path. So we're returning the path to that model if the file exists. And then, to load the model, we create or instantiate an interpreter with that model path and allocate tensors for it and return it. So we load the model. Where is that being called? Here, and then prediction, we just have a function to get the prediction. So first we get the model and the signature from get model and signature. Then we get an interpreter by loading the model. We make a prediction by calling get prediction with an image, an interpreter, and a signature, and then we return the prediction, right? That's the main function of this command. And is file, couldn't find image. We could, as I've said, we could make a batch of images and send it, but we'll have to adjust the script. We have a script to process the image, and then want to get the prediction. So we use the signature include on the JSON file to make that operation. All right, great. So we're gonna see how to connect this to Runway some other time, not today. And we have that TensorFlow Lite model that we've trained today, and we were able to use it with code in Python TensorFlow Lite, and we could deploy. And all right, so let's get back at the at this Pix2Pix app that I was showing before. Okay, so Nate Peters and I have shown this before on the channel. So Nate Peters and I, together with Jose Luis Garcia del Castillo, prepared a demo for Pix2Pix and Runway. So you can see some of those videos here. So he has some videos, and I have some as well of how we build this. And this was just an attempt to build an application that you would be able to interact both with rectangles and with a brush in order to draw things and get real-time predictions. So an interactive application to get machine learning predictions. And again, there's a full video on this. What I wanted to show you, the second part of today, that we're already 2 hours and 15 minutes in, was that Runway is also a tool in some way similar to Lobe, a bit. I think the ecosystem that they're creating is really different. Their slogan is machine learning for creators. Lobe is deep learning for everyone. But if I bring Runway here, they have this model store or marketplace where a lot of people can create models and expose them. So there's this Pix2Pix model that Nate and I exposed, right? And I have a workspace for already. So how does this work? So we could get images from the webcam directly and perform operations there. We can get images from disk, or we can get images from an HTTP server. In this case, what Nate and I were trying to do is to have this application here be a drawing app for interacting with Runway in real time. So for this might slow down my computer a bit. So I'm gonna start Docker on my machine. You can create a Runway account and download this model by clicking in here. So you can go there to pix2pix.glitch.me. I'll paste this on the Discord channel and in the live channel of the Discord server. And you can open this application and we're going to see how to interact with this. So Docker is starting here. So Docker desktop is starting. And once it starts, we're going to be able to run the Pix2Pix machine learning model Docker image, which is what's called a Dockerized environment that has all the dependencies for these to run. We're going to run it and we're going to see how that works. All right. Let me paste that there. Okay. So, not sure how fast this is gonna go. It seems like computer is slowing down a bit. Let me just listen to that. All right, we have Docker here. Oh, CVAT is running. Why? Why is this continuously running? Well, CVAT is a labeler. All right, so once we have Docker running, you would probably, you will have to click here on the model. And so you will have to click on download here, and then you have to download one of these datasets. But if I click on run locally, because I've set up everything already, we now have, well, when this gets started, we're going to have a Runway image or a Docker image from Runway running locally on my machine. What this is going to do, one of the things it's going to do is create an HTTP server, something like we saw before with the local API function in Lobe, where we're going to be able to interact with that, sending images as well. So right now we have youthful wilds. This is the random name of the Docker container that we're running from Runway. This might take a while, but even if it's going to take a while, I'm just going to get started here sending requests. So I'm just gonna make a cube. And see what happens there. Okay, what do you think is gonna happen? So we're gonna get something here. So this image here is going to appear here as an output, and we're gonna see it right now. Let's see. Okay, I'm gonna hide myself again just because it's gonna start going slow, but we still have audio. All right, this is working now. Okay, yeah, one thing that's happening, I'm sending requests, but I didn't put the right port, so the server address is 8000 here. I think you might be able to edit that, but yeah, we can edit it here. So once we do this, we're gonna be able to see that. Nice. So we have the the cubic Daisy. So this is a Daisy cube. Just gonna save this. Oh no, can't really revert that. Right, let's see what happens. Okay, yeah, this is what I always do, but this model was made for data like this. So this type of data set is what it was trained with. Okay, so what's going on here? What's the gist of this? So we have a machine learning model that somebody, in this case Nate and myself, put together as a program that can be served on Runway with the Runway SDK. Then you upload that model there, Runway puts it on their server, and then anyone can click a URL and download that model in Runway, which is a Docker image. Once you click on run, it spins up many things. One of them is this HTTP server from which you can interact. And let's see, does this save the image? Yeah. And and we have, I'm just gonna save this here and get those images as well. Actually, let's just fix this one because I broke it. Right, and what happens here, if I wanted to download one of Nate's models, so he has this floor plan, and well, I have to stop the model and download the checkpoint. So I'm gonna download the floor plans houses checkpoint. This is probably just gonna take 1 or 2 minutes. All right, and once we here this thing says that the video is not receiving enough streaming data. Is that true? Is that, fix this one because I doesn't look bad from here. Okay, still downloading, and I'm just gonna fix this image quickly before we keep going. All right, this is being a pretty long live stream. Okay. Okay. So, what's about? That's almost downloaded. Okay, one thing for anyone who watches, we are just putting together the Discord server. So this is under Getting Simple, that's the name of the podcast. But we'll just have the live channel here, the introductions channels, and we'll get started with this channel. I don't know if we'll create a different channel for the live stream or the YouTube videos and stuff, but for now we'll get coordinated in there. All right, so this has downloaded, so now we can run locally this model that Nate trained that is more suited for these rectangular shapes. Runway receives information really quickly because it's a local server, the one that is actually receiving this information, but the model is still not running because the Docker image hasn't been initiated. So the one thing I want to do is on the next videos, we didn't wrap, I don't think we were running a TFLite model. Maybe we were, but at the end of the day, we are, yeah, probably we were, I need to check. We want to run our model and be able to run it in something like Runway, for instance. So say we've trained a model, we have an environment that is Runway, and we want to be able to run our models in there. So we want to know how to create a Runway model. Okay, so this is working now. We can talk a bit about it. All right. So this runs pretty fast for being streaming, having Docker open and the image running and stuff. This is running pretty fast. Okay, so that's working. And as I said, there are classification models here as well, and we could make or like wrap a model that we train with Lobe and run it here on Runway. So we're gonna stop it. Okay, I forgot we could feed a live feed of images or webcam to Runway. Okay, so the one thing that I didn't get to do, that I don't know if I have something to show you, well, maybe I didn't do more things that I'm saying, but let's just take a quick look. So let me see. Oh, I have many ideas of things that we're going to be seeing on the live stream. Okay, so we've seen TensorFlow. So the TensorFlow Lite versions are all these get out, all these versions that you can install the interpreter with. So you have different versions for Linux, different versions, architectures for Mac, Windows. So it goes up to 3.7 of Mac, and that's why on the environment that we had before, so Conda environment, Conda activate, TFLite, this is why if we look at this environment, we do which pip, we can say Python version, and it was 3.7, right? This is why we didn't have 3.8 there, or why Lobe is shipping with 3.6. They might have optimized everything for that. TensorFlow Model Maker. And yeah, so and this is the base code of how you initialize a model that we've seen with the Runway boilerplate code. So the Lobe boilerplate code. There is some there are some handy functions to create models with TensorFlow Lite. Okay. And well, we've seen Runway, we've seen the demo of the Pix2Pix app. We haven't seen the boilerplate. We've seen this. Oh, what is this? Code challenge, right? TensorFlow model converted to TFLite running on the iPhone. Yeah, we're not going to do this today or this one. So here we have a notebook that Nate adjusted, but I think it's provided by Google, TensorFlow, which is a notebook to train Pix2Pix from scratch with your own data. So in this one, it reads or tries to mount your Google Drive here as a folder, and then you just specify a folder, and then you can train and download the dataset, and then download the train model, and then upload it as a checkpoint on Runway to be able to use it, as we saw, as an input-output generator. Okay, so the React Electron, do they have anything for that? Let me check. Well, let me see. So node model folders can be huge, and I don't understand why this takes so long. But on the meanwhile, let me just go quickly here. We can cancel that, and I need to clone it. All right, yeah, so this is, let me see what this is. So this is just a React application, or is it? Let's see. Node, React, eject. Okay, so if I do npm start, what happens here? Okay, this started this window here. We have here the app. So this is, this is the React application with TypeScript. This is a boilerplate, but what I'm more interested in is on putting this inside of Electron. So this right now is running as a website, so server served locally, as we were doing before with the Runway and the Lobe models. But and this has hot reloading and stuff, so we could change something here, and then this recompiles and then updates there. It even tells us if there are errors and stuff to do this, right? There's no number. So yeah, this was telling me to test Stitches, which is a library that I want to test. Server-side render. Yeah, so let's look for a React So Electron, React, TypeScript, boilerplate. I think I had one, but probably doesn't work anymore. Electron, too many things. Electron, Webpack, TypeScript, React, Redux.js, and auto reload. Yeah, so this is what I would like to get updated to today. So we have, this hasn't been updated for the longest time, but I'm sure some of these are being kept up to date. Maybe not this one 3 years ago. Or maybe we can build our own from scratch, but you know, Electron, React, TypeScript. Well, let's just try this one quickly. See if this works. Right, so I'm cloning, I'm getting into the folder, and I'm installing all the npm packages. Well, if you're watching right now, feel free to introduce yourself and let us know who you are, where you're connecting from, and what you would like to see on future live streams. Server. Right. Let's see. Okay, this takes a bit because he has to download Electron and download all the dependencies, and he's installing them right now. Right. Okay, so this is working. So npm run server and npm run start when that's done. So this is the web dev server that runs there, is running there, and then npm run start to run the application. There's a lot of stuff that is already being done for us here, which is really cool, but at the same time obfuscates a bit of the code and makes us not understand. The reason why I'm doing this right now, is because, you know, whoa, okay. All right, so yeah, this is probably what I was looking for, not with this layout there, but yeah, okay. It seems like we have live reloading and we're developing an Electron app, and we can call the command that was on the readme, so npm run pack, and then we can run the application, build the application for production. So this would be an app that is distributable for other systems, other people. So let's see if that works. And you know, that just as a recap, that's something that I want to get back at, because I've built Electron apps before with React and TypeScript, and I think it would be a good exercise to build a custom application that, you know, has some sort of interactive environment and lets us play with some of the machine learning models that we're going to be training. Maybe a simple linear regression regressor, or a neural network, or other types of models. Right, let's see, wrote new app to blah 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 pack. Okay, so the new app was written here. So this, you know, this is an app that includes the core of Chromium, so Google Chrome. And as you can see, we have, this is our application. There's nothing, we have our icon in here. We haven't really done anything, but if we had an application, we'll have it running here. So we can now create Docker, create this, and let's see what we have here. So we have this model, which I'm not gonna upload because it's 104 megabytes. Maybe just do like live offline or something. And for now, we'll just do live 4. We'll just copy this here. And this was 23. Live 3. And you know, this is for the future. We haven't really done anything with that. Okay, I'm not sure what I'm gonna do with that, but yeah, there it is. So let's just do something here. So let's go to projects, talk, live stream, and tutorial, call to action. So, well, I have here just the last thing. So let me open this here. Well, just to wrap up the video, so I hope that you're enjoying these sessions. This is for me a moment to experiment with new things and learn about machine learning as well, and show those things to you, and probably try to communicate those concepts. I'm really happy that you joined us today on this machine learning series video. I would encourage you to like the video if this is the type of content that you would like to see more of, and subscribe if you want to get notified when I go live next or when I upload new videos. Make sure to also join the Discord channel. There is a link on the description of this video. And yeah, thanks so much for watching, and I'll see you next time. Just as a last comment, you know, there's a bunch of things, or there are a bunch of things that I have here that we've gone through already on the live stream. So this was live number 1, live number 2, and number 4. So I keep cataloging or like documenting everything that we're trying to see on the channel, and many other things that I think we're gonna be able to go through in the near future. So this list is huge because as things come to me, I write them in this document and start thinking about what things we could see. I would like to hear from you as well. So if you have any ideas on what you would like to see first, just let me know, because that will highly influence what I cover on the live streams. And yeah, so again, thanks for watching, and I'll see you next time. Bye. Thank you.